right, we're going to go on to our last section of chapter 8. It's 8.3, testing a claim about a mean. Now, if you remember, a mean is mu. So there's two parts to this. You either know sigma or you don't know sigma. So the first part is you don't know sigma. So what test do you do if you don't know sigma? You should all know this. We're going to be using a t-test. Okay, so some notations that you guys need to know is you need to know n is your sample size. And you're like, wait, we do this every single time. I know I kind of like talking about each variable. We use S, because we don't know what sigma is, to be your sample standard deviation. Okay, and we know X bar to be your sample mean. And we're going to use mu to be your population mean. Okay, so same thing we've been doing pretty much the entire time. Okay, so some requirements. Now, this is not a proportion, this is mean. So there's still only two things to check. The first one, again, is SRS. But the second one is not an SRS. It's not NP and NQ because we don't have P and Q. We have a number. So we have to remember there's three options. The first one was that it says normally distributed and you're good. Okay, the second one was that n is greater or equal to 30. So by CLT, central limits theorem, it's approximately normal. And what happens if it's not either of those? You guys are your favorite, right? Otherwise, you have to draw a box plot. And what do you have to say? You have to say no strong skewness or outliers. Skewness, not mess. Or outliers. Okay, again, we're going to do an example that deals with all of that. Okay, so test statistic for a proportion. So there's two ways to do this, again, by hand and by calculator. So I'm going to go ahead and do both pretty much the entire time, which is nice for you guys. So we don't know sigma. So if you don't know sigma, we'll be using a t-test. Okay, and again, if you look at section 8.1, I did write out the formula out again. So it's x bar minus mu over s over square root of n. Okay, we used this formula a lot last chapter too. And then after that, what do you use? You use TCDF. Okay, so use TCDF after words. And you have to know, again, if it's left-tailed, right-tailed, or two-tailed. And then you're going to use degrees of freedom of n minus 1. Okay, and then you're going to find the answer you get is called your p-value. That's if you're doing this by hand. And if you're doing this by calculator, you're going to write a t-test. Okay, it's in the same spot as before. You're still going to go to stat tests. It's your t-test, which is going to be, I'll look it up for you, number 2. Okay, and then you have to write out all the variables. Write out all variables. And I can't emphasize that enough. And then you still get your p-value as one of them. Okay, and then the last thing you would do is go ahead and write your sentence. All right, so we're going to try an example doing this. We're going to do 2 examples. So if you want to try one and then pause it and see how you do, you're more than welcome to. Actually, we have a couple of them. We don't have that many. So we're going to go on to the next page. All right, so it says example 1. The author obtained times of sleep for randomly selected adult subjects, including the National Health and Nutrition Examination Study, whose times and hours are listed below. Here are the unrounded statistics for this example. Notice it says unrounded, so when you write this out, please round. Remember, 3 decimals is good to go. N is 12, X bar is 6.83333, S is 1.92, and so on. Okay, a common recommendation is that the adults should sleep between 7 and 9 hours a night. Use the p-value method with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. Okay, so we're going to go ahead and do our state, plan, do, conclude, and I'm just going straight into this. Notice I'm kind of like no notes or stuff. It's just like straight an example. So first of all, state. Okay, this time we're not using proportions. We're using mean level. Like we're looking at amount of sleep, the mean amount of sleep. So what is the variable we use for mean? Well, we're looking at the basic of a population. We're trying to state this to be the entire population. So we're going to say let mu equal mean amount of sleep for adults. That's it. Done. Okay, and then our ho. Now remember, our ho is always equal to, so we're going to use the variable from our mean and say it's sorry, it's not 0.7, it's 7. Why did I get 0.7? It's 7, less than 7 hours. That means your ha is, your mean is less than, so less than I keep saying 0.7, it's just 7. I'm so used to proportions. Okay, that's our first part. Okay, our plan is to go ahead and check our requirements. So the nice thing is this one was randomly selected, so it actually said it. So I'm going to say SRS, check. The next one is we do have to check if it says normally distributed, which is the sad thing, it doesn't. So we can't use that method. It's N is not greater or equal to 30, it's 12. And so we're going to have to use our box plot method. Okay, so we're going to go ahead and draw our box plot. And how do we draw our box plot? Straight as we've done it before. So we're going to enter it into our data. Okay, I'm going to clear it. I'm going to go ahead and enter it in. So I'm going to do 4, 8, 4, 4, 8, 6, 9, 7, 7, 10, and 8. And I got 12 numbers. I'm good to go. I know I did it right. Okay, and the next thing I'm going to do is go ahead and hit stat plot on, make sure everything is correct, and then I hit zoom 9. I'm going to go ahead and sketch that. Okay, so I've sketched it. I'm going to say, what do I write? No strong skewness or outliers. And I know I did that fast, but we've been doing this since like before I even left campus. We've done that. So we're good to go. We're going to go ahead and calculate this. Now, our do part, I'm going to again do it by both ways. You just get to pick one. So I'm going to do this by hand and by calculator. Okay, so if we're doing this by hand, well, since I don't know what sigma is, I'm going to be using a t-test. So I'm going to say t is equal to, and it's x bar minus your mean. So x bar is 6.833. And notice I'm not writing it all out because I'm rounding to 3 decimal places. Minus your mean. My mean was 7 because that's what our mu is. So I'm going to write out the formula here. It might be a little easier. So x bar minus your mean over your s over the square root of n. Okay, so I have x bar minus mean over s in this problem is 1.992 over the square root. And how many people were looking at? I was looking at 12. I'm going to go ahead and calculate this out. So I'm going to do parentheses 6.833 minus 7, close my parentheses, divided by parentheses 1.992. And I like putting as parentheses at the bottom to show that, like, I understand it's in my denominator. And then I do a divided by square root of 12, and then I don't really have to close it at the end because it'll calculate it for me. And I get negative 0.290. Okay, now here's my question to you. Since it's less than, is that a left-tailed test or a right-tailed? Well, since it's less than, it's going to be a left-tailed test. So we're going to go ahead and use TCDF. Okay, and our minimum, so since it's less than, is going to be negative 1,000. Our upper is negative 0.29, so negative 0.29. I just got the answer here. And our degrees of freedom, remember, is n minus 1. So there's 12 people, so it's 11. I'm going to go ahead and label that. So I'm going to say this is your lower, this is your upper, this is your degrees of freedom. I'm going to go ahead and calculate that. Oops. So I have negative 1,000, negative 0.29, and 11. And I'm going to get 0.389. Okay, and that right here is called your p-value. Okay, so we're going to go ahead and do this by calculator. So if we're doing this by calculator, we're going to go ahead and do a t-test. Okay, so I want you guys to go ahead and find it. If you're doing it by calculator, I totally dropped all my notes. This will be fun as I'm recording. Found you. Okay, so, sorry, t-test. We're going to go ahead and go stat, tests, t-test. This is statistics, so our mean is 7. Our x bar I wrote out as 6.833. Our s sub x is 1.992. Our n, how many people did I look at, was 12, and it's less than, so we're good to go. And I'm going to actually write all this out. So I'm going to say mu of 0 is 7. X bar is 6.833. S sub x is 1.992. N is 12, and mu is less than mu sub 0. I'm I'm gonna go ahead and hit calculate. I'm gonna write all my values out. So I got t to be negative 0.29, which is exactly what I got here. And our p-value to be 0.388, which is very close to what I got over here. Our x bar is already written. Our s sub x is already written, and our n is already written. Okay, so I pretty much did the same thing, except one's by calculator, one's by hand, and you get very close to the same answer. Okay, and if you do it either way, you're gonna get the same answer. All right, our last part is our conclude, which is our sentence. So I'm gonna write p-value is 0.389, which is actually gonna be greater than alpha. Okay, alpha is always 0.05 if I don't tell you, but I did tell you it's 0.05 over here. So what are we gonna do? We are going to fail to reject oh, and I'm just using the sentence frame, so just make sure you have them out. I'm gonna say there is no sufficient evidence that the mean amount of sleep for adults is less than 7 hours. Okay, and again, that's an entire problem all the way through. So let's go ahead and do another example. I'm not gonna do every single step. Again, if you wanna pause it and write it out, you can. I'm just gonna go ahead and write my ho and my ha. But essentially what you're doing is you're looking at the mean body temperatures, so your mu would be mean body temperatures, but I'm not gonna write all that out. In your SRS, well, I'm assuming since it's from a data set, I gave it to you. So SRS is good. Your N is greater than or equal to 30, so you're good to go. So let's go ahead and just write ho and ha. And again, it's just more quick having some extra practice. So it says use a 0.05 significance level to test the common belief the population mean is 98.6. Notice it didn't tell me if it's greater than, it's less than. We're just assuming it's 98.6. So we're gonna say the mean is 98.6. Okay, my ha. Now since it didn't say less than or greater than or any of that information, my ha is going to be not equal to 98.6. So if it doesn't tell me, we're gonna assume it's just not equal to. Okay, and then it says use alpha to be 0.05. All right, so we're gonna go ahead and again, I'm not gonna do all of this, but you have to do the next part by either calculator or by hand. So if you're doing this by hand, you're going to get your t value to be negative 6.64. And then you're gonna think about, okay, so you're gonna use TCDF. And if it's negative 6.64, I'm gonna go from negative 1,000 to negative 6.64 because it's on the negative side. And then my degrees of freedom is going to be 105. But since this is a two-tailed test, what do you have to do with your answer? You actually have to multiply it by 2, okay? And that's because it's a two-tailed test, if you remember from our first section. Okay, so I'm gonna go ahead and just type that in here. So I'm gonna do second distribution, TCDF, negative 1,000, negative 6.64, and we're gonna do 105. And I get a really small number, and I'm even gonna multiply it by 2. Take answer and multiply it by 2. And again, please know that this is 1.419 times 10 to the negative 9. Do not write e to the negative 9. That's not the correct notation. Okay, so let's go ahead and do this by calculator. So by calculator, you're gonna use a t-test. Okay, and you're gonna write out the important information. So I'm gonna go back to tests. T-test, and I'm going to go ahead and say our mu sub 0 is 98.6. 6. Our x bar is 98.2. Our s sub x is 0.62. Our n is 106. And we're looking at not equal to. And I'm going to hit calculate, and it automatically gets me t to be negative 6.64, which is exactly what I got here, and our p-value to be 1.4 times 10 to the negative 9, which is exactly what I got here. It's a little bit more precise. Here's my thing. This is 0.00008 times if you think about it. So if that's the case, we're going to say p-value is 1.4 times 10 to the negative 9, which is actually less than or equal to alpha because it's so small. Okay, so if it's small, if your p-value is small, what do? You reject Ho. So reject Ho. And then you ask yourself, there is sufficient evidence, and it's the same sentence frames, which is nice. There is sufficient evidence. Sufficient evidence that the mean temperature is not 98.6 degrees. Okay, so I rejected the Ho and I accepted the Ha. And the Ha was not equal to, so I just say is not what the Ha is. Okay, that's what happens if we know what sigma is. All right, so we're gonna do pretty much the same thing as we did before. We're gonna know what sigma is this time. Okay, and then we'll do another example all the way through. Okay, all right, so this time sigma is known. So if sigma is known, we're going to be using a z-test. So your test statistic is going to be your z-test. Okay, so there's two ways of doing this. The first thing is you're going to go ahead and we're going to do this by hand. So if we do this by hand, it's x bar minus your mu over your sigma over the square root of n. And then you use normal CDF. Okay, if you do this by hand, this is by hand. If you're doing this by calculator, if you're doing this by calculator, you're going to use the z-test, and then what do you have to do with it? You have to write out all information. Okay, this is actually the first test you do. I know it's weird, we teach you the first one almost last in this section. Okay, your p-value, same thing. It's going to be the probability. So if you're doing this by hand, it's the normal CDF part, and if you're doing this by calculator, it's whatever your p is. Okay, depending on what it is. Your critical values are just a fancy way of saying what's your z-score. Okay, that's your critical value, but like really it's the same step as your test statistic, pretty much the same thing. The one thing I forgot to write is your requirements. So SRS, and I'm gonna write requirements over here. I'm gonna say SRS is the first one, and your second one, you have 3 options, and I'm not gonna write all 3 out, but you should know them. So it says normally distributed, or n is greater or equal to 30, or you draw your box plot. Okay, so I'm gonna go ahead and do an example. So it says go back to example 1 from 8.3, so just literally the back of this paper, and now use n is 12, x bar is 6.833, and sigma is 1.9924. Okay, so I'm not gonna do all of the problem again. I'm just gonna kind of do the Ho and the Ha. So your Ho is going to be, remember, your mu is 7. This is the amount of sleep, and your Ha is mean is less than 7. And so again, remember, it's your left tail test. Okay, and we're using alpha to be 0.05. Okay, if I don't give it to you, that's what we use. Okay, let's do this again by hand and by calculator. Okay, so if we're doing this by hand, we're going to do z equals x bar minus your mean over sigma over the square root of n. Okay, so if I'm doing this, my x bar was 6.833, my mean was 7, and I know that because that's what my Ho and my Ha say, over my sigma, which was 1.9924, over the square root of 12. And you could put 1.992, that's fine as well. Okay, so I'm going to go ahead and calculate that. So parentheses, 6.833 minus 7, close my parentheses, divided by 1.9924, divided by the square root of 12. And I'm going to get a number that I shouldn't have gotten because I forgot to put the parentheses. There we go. I forgot to put a parentheses here. Please make sure you do because you'll get it wrong. It's going to be negative 0.29. Okay, now since we're going left, we're going to go ahead and find the area by doing normal CDF. And we're going to go, since our lower is negative 1,000, our upper is negative 0.29. Then we have 1, 0, and 1. I'm going to label this lower upper, mu, and sigma. And when I do this, I get 0.386. Okay, now that is by hand. By calculator, I'm going to write z-test. And a little good thing, like the hard thing is you have to figure out what test it is. It's not a proportion because there's no p. And then if you go to test, you can kind of figure out what you need. And once you do that, you can kind of figure out what answers you need. So you need to fill in mu sub 0, which is 98.6. Your sigma, which was 1.9924. So I have to change that. 1.9924. Our x bar, which was 6.833. So 6.833. Sorry, mu sub 0 wasn't 98.6. It was 7. I'm doing the wrong problem, but 7. Our n was 12. And our ha is less than. And I'm going to go ahead and hit calculate. And I already wrote mu's less than 7. I'm going to write my z-score, which is negative 0.29, which is exactly what I got here. And our p-value is equal to 0.386, which is exactly what I got here. Okay, so our p-value, is it less than or greater than alpha? It is greater than. So we're going to write p-value is 0.386, which is greater than alpha. So if your alpha is bigger, or if it's greater than alpha, what do? We fail to reject Ho. And we're going to say there is no sufficient evidence. There's no, not. There's no sufficient evidence that the mean amount of sleep is less than 7 hours. Cool. All right, moving on to the next page. This is our last page. Now, I realized I did the same question. I was going to do like an extra practice question, but I already did an 8.2, so I don't have one for you. But I wanted to do a summary, but I wanted to write a little bit bigger, so I'm going to go ahead and write it in the back. But it's pretty much the summary of this entire chapter. The one thing I didn't include is the type 1 and type 2, so I'm just going to add that at the bottom, but you should practice those as well. Okay, so for hypothesis testing, there's 2 ways to go about it, and you have to know what way to go. So the first way is using proportion. Okay, and this is 8.2 if you want to think about it. And the other way is looking at mean, which is 8.3. 8.1 is just a ton of vocab. Okay, then in proportion, what kind of test do I do? Well, there's only one possibility. You're going to use a z-test. Okay, and you can go 2 ways about this, but before we do that, let's go and write out the requirements. What are the requirements? We're going to go ahead. Well, let's go ahead. Yeah, so our requirements are going to be NP is greater or equal to 5, and Q is greater or equal to 5, and it's an SRS. Okay. The mean, now it breaks out into 2 things, but we're going to go ahead and either use a z-test or a t-test. Okay, now before we break it up even more, our requirements are actually the same. So my requirements, so these are the requirements. My requirements are the same for both of them. So the first one is SRS, and the second one is the ones that we always list. So I'm going to just write the 3 to choose from. 3, choose 1. And I'm not going to write them all out, but they're the 3 requirements. And you should write them out, and you should know them. Okay, now when do we use, for a z-score, what's our formula for z-score? So I'm going to break this up. I'm changing my notes again. We're going to do this by hand and by calc. So by hand and by calc. So if we're doing this by hand, we're going to use z equals p hat minus p over square root of pq over n, and then use normal CDF. If you're doing this by calc, you're going to use a 1-prop z-test, okay, and you're going to list out variables. Okay, pretty simple. And then from here, you're going to find your p-value, and you're going to write sentence. Okay, and that's it. All right, so for this one, or mean, it breaks out into two. What are my two methods? You know sigma or no sigma. Okay, so if you know sigma, what test am I using? I'm using a z-test. And what's your formula for z-test? It's going to be z equals x bar minus your mean over sigma over the square root of n. Okay, and then you use normal CDF. Okay, if you're doing this, so this is by, if you're doing this by hand. If you're doing this by calc, okay, you're going to use a z-test and then write out variables. But either of those answers, you're going to go ahead and write sentence. Okay, now what happens if you don't know sigma? Okay, well, I can't use the z-test because that deals with sigma. I'm going to go ahead and do a t-test. Okay, so you're going to do t equals x bar minus your mean over, and I can't use sigma, so it's s over the square root of n. And then you use TCDF. Okay, that's if you're doing it by hand. By calculator, you're going to actually do a t-test. I'm running out of space. I'm going to write it over here. You're going to do a t-test and list out variables. Okay, so it breaks up into here, and then either method, you're going to write sentence. Okay, and then the last thing you should look up is, that's pretty much 8.2 and 8.3. For 8.1, I would look up a type 1 and type 2 error. And that's pretty much all of chapter 8. Thanks.